Chapter 10, Electricity and Circuits. You will learn history of electricity, conductors and insulators, safety rules, sources of electric current, flow of electric current. Quick review. We use many applications which need electricity to work, that is light, fans, televisions, washing machines, mixers, refrigerator and air conditioning. Today, electricity has become indispensable for our daily life and we cannot imagine life without it. History of electricity. The word electricity originated from the Latin word electricus, which means amber. Greek philosophers noticed that a piece of amber, hardened resin from pine tree, could attract pieces of straw if it was rubbed with cloth. Later, it was found that the rubbing produced electrical charges in the amber. Electricity is one of the most useful forms of energy. It can be transformed into different kinds of energy using suitable devices. Some of the transformations of electric energy are as follows: light energy, electric bulbs, fluorescent tubes, CFL and LED bulbs; sound energy, TV, radios, transistors, loudspeakers and tape recorders; mechanical energy, electric motors, mixer grinders, vacuum cleaners and electric lifts, etc. Magnetic energy, electromagnets, electric bells and transformers; heat energy, room heaters, geysers, electric iron, ovens and toasters. The flow of electrons is known as the electric current. This electric current passes through the devices which run on electricity. From where does the electric current come from? There are different sources of electric current which we will study in this chapter. Real life connect. Electrical energy is used for several devices. Electric energy is converted into one form to another. In which form electrical energy is converted in the following items. Sources of electric current. A device that can be used to produce an electric current is called a source of electric current. Electric cell, dry cell. A dry cell is considered to be a very convenient source of electricity as it is easy to carry around. It is commonly used in torches. The figure shows the outer and inner view of a dry cell. The dry cell contains a zinc container which holds paste of ammonium chloride, a cardboard container containing powdered manganese dioxide, and carbon is placed within the zinc container in the center. The cardboard container has microscopic holes in it, also known as porous material, through which a chemical reaction takes place between ammonium chloride paste and powdered manganese dioxide. A rod, usually made of carbon with a metal cap, is dipped into the manganese dioxide. This whole arrangement is sealed, expressing only the metal cap outside so that the content do not spill out. The zinc can is also wrapped. Every electric cell or dry cell has two ends where wires are connected to draw electric current. These two ends are called the terminals of a cell. The tip of the metal cap and the base of a zinc are the positive and negative terminals of the dry cell respectively. Electric current from one terminal to the other terminal. When the tip of the metal cap, positive, and the base of zinc can, negative, of the cell are connected through a bulb, the electric current flows through the circuit and the bulb lights up. The electric cell or dry cell is also known as the primary cell, as once it is used up, it has to be discarded. Secondary cells are the cells which can be recharged and reused once they are drained. When two or more cells are used in a single device, the group is called as battery of cells. These type of cells are used in the mobile phone, laptops and car batteries. Solar cells are also type of secondary cells that are used in many applications such as calculators and batteries. Solar panels made up of solar cells used in street lights which store the solar energy in the daytime and use that energy throughout the day. Electric circuit. The complete path from one terminal of an electric cell via the bulb and back to the other terminal of the electric cell is known as electric circuit. Let us take an example of a simple circuit connected having cell as a source and a small bulb connected to it. When the electric circuit is complete, electricity starts flowing from the positive terminal of the electric cell to the filament of electric bulb and from there to negative terminal of the electric cell as shown in the figure. The complete path is called closed electric circuit. If the electric circuit is broken at any point in its path, then the bulb does not glow. Such an electric circuit in which path of electric current is incomplete or broken at some point is called incomplete electric circuit or open circuit. Electric switch. Let us imagine that the bulb that is glowing in your house is connected directly to the electric source. What will happen if we want to stop the glowing of bulb? We cannot every time disconnect the source and the wires from the bulb. It is inconvenient, impractical and unsafe tool. To enhance the convenience of use of circuit, a device called electric switch is used. When the switch is in the on position, the circuit is complete and the current will flow. The electrical appliance start working, but when the switch is in off position, the circuit is incomplete. Hence, the electric current cannot flow through the circuit and the appliances do not work. There are many types of switches and they have number of uses. They are also used to change the direction of electric current. A switch can be mechanical or electronic. The household wall switches are mechanical switches. A television set is remote controlled with a combination of several switches on the TV remote. It has electronic switches. TV remotes that we use so frequently on daily basis is a type of electronic switch. In this remote, there is a small processor that controls all the functions of the remote. Whenever you press a button of the remote, the processor triggers the light emitting device at the front of the remote to send signals. The type of signal produced depends on the button that has been pressed. For example, the signal for changing the channel is different from the signal that switches off the TV or the switch that controls volume. Electric circuit can be drawn using symbols. An electric circuit will have the components bulb, wire, cell and a switch. The components are symbolically shown as under. The open circuit in which the electric current does not flow. The closed circuit in which electric current flow. Wonder why? Take a piece of wire with a sharp knife, cut the outer covering. What do you see inside? You will find copper wire. The electric circuits always have a metallic wire used in them. You cannot use a plastic or rubber wire while making electric circuits, but the outer covering is always made of rubber or plastic. Have you ever wondered why? Let us find out why by studying conductors and insulators. Flow of electric current. We have discussed about the source of electric current and the electrical appliances which run on electricity. There are three basic conditions required for an electric current to flow. The complete circuit for flowing of electric current is as shown in the figure. Due to the flow of electric current, the filament of bulb becomes red hot and starts giving light. The two terminals of the cell with the wire must never be connected without an appliance or bulb connected in the circuit, as this will cause overheating of the wire and will destroy the circuit. Electric bulb. Now we know an electric circuit is and how a bulb connected to a circuit glows. Let us study how an electric bulb works. The bulb is made of thin clear glass. Inside the bulb there is a thin wire, also called the filament, is made of tungsten metal. Tungsten is a metal which melts only at a very high temperature. The filament is fixed to two wires. One of the wires is attached to the lower side of the bulb called electric contact, and the other is attached to the bottom of the bulb called screw thread contact. These two connections of thick wires are the two terminals of the bulb. The bulb is a partial vacuum and is filled mostly with argon gas, which is also called inert gas. This gas protects the filament from burning and thus protects filaments. When electricity flows through the tungsten filament, it becomes extremely hot. It begins to glow and produce light. The hot filament also produces heat. Thus, a bulb converts electricity energy into light and heat energy. If the filament breaks, the circuit breaks and electricity cannot flow through the bulb. Such a bulb is said to be fused. A fused bulb cannot produce light and has to be replaced. Nowadays, light-emitting diodes or LEDs are being widely used in many of the electrical appliances instead of ordinary bulbs. A LED has thick metal strips instead of the thin delicate wire of the bulb. Hence, most LEDs last for about 100,000 hours or 11 years. They consume less electricity and do not produce heat like electric bulb and are almost unbreakable. The longer wire of LED is the positive terminal of LED and is connected to the positive terminal of the electric source. The shorter wire of LED is the negative terminal and is connected to the negative terminal of the electric source. Light torch. Have you ever looked inside torchlight? How does it work? The principle on which the torchlight works is very similar to a simple electric circuit with a source and a switch connected in it. The following figure shows the schematic diagram of an electric torch. An electric torch has one or more dry cells inside which act as the source. These cells are connected through a switch to a small bulb. When the switch is pushed to the on position, the circuit is complete and the bulb glows. When the switch is pushed off position, the circuit is incomplete, broken. Now the current cannot flow through the circuit and the light goes out. Fascinating fact. Electric cables are fixed on tall poles to keep them out of reach. These cables are not insulated. Huge amount of electric energy passes through these wires and would kill people if they came in contact with wires through shock. How does electricity reach our home? Electricity is produced in powerhouses or power stations. It is transmitted to our homes, industries, hospitals, schools and other places through a vast network of overhead cables or underground cables called the electricity grid. Real life connect. Safety rules. Electricity when used improperly can be very dangerous and it could even kill. Listed below are some safety rules that should be observed at all times wherever electricity is involved. Never touch a switch with wet hands. Never overload a connector. Never put electrical wires under a carpet or rug. Put a metallic item in a fuse box. Never operate any electrical gadget while standing on wet floors or surfaces or when you're wet. Never open any electrical appliances to check when the switch is on. Avoid standing under a tree during lightning and thunderstorms. Never touch any broken cable or power line. If you suspect that it is in contact with a puddle of water, especially after a rain, don't go any near it. Never go swimming in an open lake during a thunderstorm. Our body is a conductor of electricity. We must take all necessary precautions while handling an electrical appliance. Subject integration. We utilize electricity in all aspects of our lives as listed below. Related to commercial usage. Electricity is used in many commercial structures such as businesses, hospitals, education centers, restaurants, retail malls, government facilities, police stations, and so on. Related to industry. In today's world, the industrial sector consumes a significant amount of power. It would have been impossible to run factories, industrial units, manufacturing processes, and other varied ranges of activities without the use of electricity. Related to daily life. Various domestic equipment and devices that require electricity range from simple to complex. These range from basic domestic equipment such as a coffee maker, dishwasher and microwave to large electrical appliances such as air conditioning units, refrigerators, electric heaters, dishwashers and dryers and so on. Related to transport. The global transportation system is fully dependent on the usage of electrical energy, whether traveling from one location to another or communicating over the world. Electric cars are widely used by the public to use electricity, electric scooters and e-rickshaws. Vehicle batteries are charged by electricity. Metro provide an alternative to fuel-dependent railway systems. Skills and values. Electrical safety is a general practice of handling and maintaining electrical powered equipment to prevent incidents. Everyone should follow safety rules like prevent electrical equipment from contacting wet areas, ensure safe use when unplugging, install properly and tidy electrical cords, etc. Batteries should not be thrown away as they contain harmful chemicals. Rapid review. Electric cell is a source of electric energy. Electric energy is produced from the chemicals within the electric cell. An electric bulb is a device which changes electric energy into light energy. An electric bulb has two terminals. The complete path from one terminal of an electric cell through the bulb and to the other terminal of the electric cell is called electric circuit. A complete circuit is called closed circuit and the current flows through it. An incomplete circuit is called open circuit. It is broken at some point and no electric current flows through it. The switch is a simple device which easily closes or opens an electric circuit. The materials which allow the electric current to flow through them are called conductors. The materials which do not allow the electric current to flow through them are insulators. Key points: conductors. The substances which allow the electric current to flow through them easily are known as conductors. Insulators. The substances which do not allow the electric current to pass through them are known as insulators. Electric circuit. The complete path from one terminal of an electric cell via the bulb and back to the other terminal of the electric cell is known as electric circuit. Electric switch. It is a device by which an electric circuit can be easily completed or broken.